Suppose Nancy has classes 3 days a week. 80% of the time she attends all 3 classes. 15% of the time she makes it to 2 out of those 3 classes. 1 day a week attendance is only 4% of the time, and she completely skips class 1% of the time. And if we consider a randomly selected week out of the semester, we can talk about this in terms of a discrete random variable. In this case, capital X, our discrete random variable, represents the number of classes Nancy attends in a week. That variable takes on values like 3, 2, 1, and 0. And those values represent the number of classes Nancy attends in a week. We can convert the given information into probability notation. So attending classes 3 days a week, we could write that as capital P, parentheses, capital X equals 3. That's our probability of our random variable taking on the value 3. And we know that's equal to 80%, or 0.80. We can convert the rest of the information into this notation in the same way. We can also turn this into a probability distribution table, not to be confused with the frequency table, although they look very similar. We'll put our random variable values in the left column, and then we'll list out all of the corresponding probabilities for each of the variable values. Last, we need to double check that this table does follow the 2 rules for a discrete probability distribution function. We need to make sure that each probability in this table is between 0 and 1, including 0 and 1. And it is. None of our probabilities are less than 0%, and none of our probabilities are larger than 100%, so we can check that off. Also, we need to double check that if we were to add all of our probabilities, that the sum would be equal to 1, or 100%. It is, so we could say that this scenario represents a discrete probability function.